So we'll now continue our discussion on the concept of a random variable, in which last time we were talking about um, assigning a random variable or assigning a variable to the outcome of our statistical experiment. Okay, and then assigning a value. Okay, a random value to that to that uh, to that variable. Now, since the outcome of our statistical experiment is essentially random, yung value na i-assign nyo dun sa variable na yung value na i-assign natin dun sa outcome ng ating statistical experiment is random, and therefore that variable that makes that variable a random variable also. Okay, so we're now on the concept of what we call a dummy variable. Okay, kasi sa mga previous examples, yung mga ina-assign natin usually the values that or the variables that we assume, okay, for most of our examples or for all of our examples so far are or tend to be assigned a numerical value. Okay, now we are now on the case where the random variable is categorical. Okay, so sabi na nga natin na yung variable we have already defined what is a categorical variable. Okay, or essentially a categorical data. Okay, so a categorical data or a categorical variable is a variable that takes on a non-quantitative value. Okay, so let's consider example 3.3, in which we will have the experiment to be the components are arriving from the production line. Okay, from the production line, and they are stipulated to be defective or not defective. Okay, so in this case, we will not be counting. Okay, hindi to katulad ng isang example natin earlier. Wala pa tayong example. This is not really like the example of picking 3 out of many components, tapos evaluating whether the 3 that you have picked is defective or not. Tapos mag-assign ka ng random variable to pertain to the number of say defectives dun sa nakuha mo. Okay, so hindi ganun yung problem natin dito. This is simply having your components classified as either defective or not defective. Okay, and that status, yung status na yun na defective or not defective. So yung status na defective or not defective, yun yung magiging mismong value nung random variable natin. Okay, but the thing is that since the random variable should take on numerical values, okay, it should take on numerical values, and the outcomes or the things that you would like to assign to X are not numerical or non-numerical. So mag-ano tayo, mag-create tayo ng dummy variable. Okay, so that is i-assign natin yung defective equal to 1. Okay, or i-assign natin si X to be 1. Okay, i-assign natin si random variable X to assume a value of 1 if the component is defective. Okay, and 0 siya if not defective. Okay, so ang idea dito kasi is that there are times that that the values or that the things or the stuff that you would like to assign to your random variable, okay, is non-numerical. Pero, kailangan kasi yung random variable niyo must take on numerical values. So, yun yung tatandaan natin. Random variables must take on numerical values. Kaya doon sa examples 3.1 tsaka 3.2 earlier, yung random variables natin take on count values. Okay? So, for example, sa 3.1, binibilang natin kung ilan yung red balls. So, count ng red balls. Ito naman, sa 3.2, binibilang natin yung tamang order. The correct order. So, the count of correct arrangement. Okay? So, count. Count, meaning numerical. Okay? Ito, count of red balls. Again, count, numerical. Okay? In the third example, in example 3.3, okay, your, the values that you would like to, or the things, the stuff that you would like to assign to your random variable x is not numerical. Okay, but rather categorical. Okay, at kapag categorical siya, again, ang gagawin natin is we assign dummy variables. Okay, so that dummy variable is given a numerical value for a certain category. So, kung ang category niya ay defective, we will assign a value of 1 for your x. While a value of 0 is assigned to your x for non-defective value. Okay? So, clearly, the assignment of 1 or 0 is arbitrary, though quite convenient. Okay? So, maraming mga experiments, statistical experiments that have this kind of setup. Okay, that is yung variable natin is to be assigned by a value that is non-numerical in nature. Hindi siya numerical in nature. So that is why mag-employ tayo ng dummy variable, and at the same time yung variable natin takes on two. Okay, it takes on two values. Sometimes it's 1 or 0. Sometimes it's actually 1 or 2. Depende sa mathematical convenience at saka depende sa mathematical convenience and kung gaano ka delikado yung paggamit ng 0 sa mga computations. Okay, kasi we know for a fact that division by 0 causes your division to fail. Okay? So minsan instead of 1 and 0, minsan they use 1 and 2 para maiwasan nila yung so that we will be avoiding the scenario wherein we have to divide something by 0. Okay? So ayun. So that's the thing. Okay? So pagka ganito, ibig sabihin nun, you have a binary variable. Binary means 2. So that means your variable takes on two values. 1 or 0, o kaya 1 or 2. Okay? Depende sa assignment niyo. Okay? So that variable, okay, that binary variable is called a Bernoulli random variable. Okay? So we call a variable or a variable that takes two possible values is what we call a Bernoulli random variable. Okay? So there. Example 4. So statisticians use sampling plans, okay, to either accept or reject batches or lots of material. Okay? Suppose one of these sampling plans involves sampling independently 10 items from a lot of 100 items, in which 12 are defective. Okay? So, for you to, no, for you to determine yung feasibility of of a batch. When you are in manufacturing and you are producing your products, okay, in batches, okay, or in lots, okay, as in halimbawa sa mga semiconductor, okay. Yung mga quality control persons, mga QC persons, either or perform quality control by inspecting batches. Okay? So halimbawa, sa isang batch, merong napoproduce na 100 items. Okay? In one batch, there are 100 items produced. Okay. Now, this is your sampling plan. Okay. Wala pala sa sampling plan. Okay. So in that batch, 100 items are produced. Okay. Now, historically, it is possible na malaman natin historically na sa batch na to, out of 100 items, okay, 12 of those, 12 items are defective. Okay? So sa 100 items sa isang batch, 12 doon ay defective. If it is known historically. Possible naman 'yun kapag ang isang quality control personnel once na magsimula yan ng trabaho, okay, nagki-keep na yan ng records ng mga results ng production. Okay? So it is possible na historically in one batch, okay, in a batch that produces 100 items, 12 of those items are defective. Okay? So now, your sampling plan now, okay? Your sampling plan, okay? Okay, is to select, okay? Is to select or randomly select okay? Randomly select 10 items sa isang batch. Okay? That is your sampling plan. Okay? So, if you now let X to be the variable that represents the number of defectives, okay, obtained during sampling. Okay, kung ito yung, if your X, okay, or if you let X to be the number of defectives obtained during sampling, then your X can take on values from 0. Ibig sabihin, sa 10 pinili mo, okay, 10 pinili mo, wala kang napiling defective. Okay? Or pwede rin, sa 10 pinili mo, isa doon defective. Okay? O kaya, sa 10 pinili mo, dalawa doon, nalaman mo defective, and so on. Okay? Up until, since 10 lang naman yung pipiliin mo, it is possible that yung lahat ng 10 mapipili mo ay defective. Kasi nga, sa isang batch, meron 12 na defective. Okay? So, which means, sa 100 items na to, okay? Sa 100 items na to, of which 12 are defective. Okay? If you are to choose 10, if your sampling plan involves choosing or randomly selecting 10 items, then, the number of defectives na mapipili mo can be as high as 10. Okay? It can be as high as 10. Okay? It can be as low as 0. Ibig sabihin, wala ka talagang mapipiling defective. But it can be as high as 10. Okay? Because, historically, we know that in that batch or in the batches of the production, 12 of them are defective. So therefore, kung 10 lang pipiliin mo, posible na lahat nung magpili mo ay lahat ng 10 mapipili mo ay lahat yon defective. Okay? So, ayun. So, there. The random variable takes on the values 0 hanggang 10. Okay. Now, suppose that the sampling plan, okay, the sampling plan now involves sampling items from a process until a defective is observed. Okay. So, iba naman yung sampling plan ngayon. Okay. So, in this case, so we don't have any number. Okay. So, pero say for example, same pa rin. So, sa isang batch, okay, in one batch, so in one batch, there are 100 items produced. Okay. And historically, 12 of those items, okay, are defective. Okay. Now, your sampling plan, okay, your sampling plan is this. Choose an item until a defective is chosen. Yan. Ito naman yung sampling plan mo. Okay? So, notice the difference between the sampling plan here, in the previous example, okay, and in this example. Okay? So, here, we will choose an item until a defective is chosen. Okay? So, ano mangyari? Our x now, okay, or our random variable x, okay, can now take on the number of items chosen before, okay, before a defective is chosen. Ibig sabihin, ilan yung non-defective items na nakuha, okay, bago makakuha ng defective. Okay? Again, the sampling plan implies that we will stop the sampling process, okay, once a defective is chosen. So in this case, ito yung mga scenario, okay? So it is possible na ito yung sample space natin, no? Let's talk this about pag-usapan natin to in the context of the sample space. Okay? So if you actually choose this sampling plan, you would be able to create this sample space. Okay? So ito yung sample space na mabubuo natin. Sa una, defective kagad yung napili niya. Okay? Next, nakapili siya ng isang defective, tapos non-defective yung sumunod. Nakapili siya ng non-defective sa una, tapos defective na yung sumunod. Okay? Then next, you'll have, you pick non-defective, and then defective. Okay? Then we stop. Okay? And then, we pick non-defective, and then we pick a defective item. So we stop. Okay? Then, pwede ring makapili mo tayo ng 4 na non-defective. Tapos yung panlima, magiging defective na. Okay? So we stop. So and so on. Okay? Until lahat ng mapili natin na 10. Okay? Or wala naman siya sinabing limit kung ilan yung pipili natin. So, we simply choose, okay, an item until, okay, a defective is chosen. So, which means, yung size nung yung size ng sample space natin, okay, is infinite. Okay? The size of our sample space is infinite. Okay? So, therefore, pero from there, we can actually determine the possible values that your x can assume or that your random variable x can assume. Okay? For example, sa unang sample point natin, okay? We see that we haven't chosen a non-defective item before we have chosen the defective. So, wala tayong napiling item before the defective. So, 0. So, x assumes 0. Okay. While here, okay, your x would assume a value of 1 dahil may napili tayong isang item before choosing the defective item. Okay. And then here, okay, your x would assume 2. Okay. Since there are 2 items chosen, okay, before choosing the defective item. Okay. And so on. So as you can see that that since your S has an infinite sample points, sabihin itong number of itong mga elements nito ay infinite. We also see that the values that your x can assume here is also infinite. Okay, it can go as low as 0, but it can go as high as infinite. Okay, ibig sabihin nun, puro defective, puro non-defective yung napipili natin. Okay. So, ayun. So, that's for example 3.5. Now, another value, okay? Another value that your or another type of value that your random variable can assume is yung tinatawag natin proportion. Okay? Proportion means fraction. Fraction of favorable over the total number of sample points. For example, if there are say 15 boys and 30 girls in a class, so yung 15 over 45 or that's 1 over 3, okay, is the proportion of boys, okay, while 30 over 45 or 2/3 is the proportion of girls. So, yung proportion na yan, pwede ring i-assume na value ng ating random variable. Okay? So, say, interest centers around the proportion of people who respond to a certain mail order solicitation. Okay? Ibig sabihin nun, magpapadala ka ng mail order solicitation. Okay? So, magpapadala ka ng maraming mail order solicitation. Say, sabi natin na ipapadala mo ay you send N mail order so you send N solicitation. Now, of course, not all of those solicitations would get a response. Hindi lahat ng bindalan mo magre-reply yan. Okay. Say for example, the proportion, the number of people, okay, who will respond to the solicitation is, sabi natin, small n. Okay. So n response. Okay. So that x, okay, if x is the proportion, okay, is the random variable that represents the proportion of people who respond, proportion of people responding to solicitation. Okay. Then, yung ratio okay, the ratio n over n, okay, gives the proportion. Okay, gives that proportion. And yung value na yan, okay, yung value na yan would be the would be the or those possible values, okay, would be the one that your random variable x would assume. Okay. Now take note na ang maximum value nito, okay, the maximum value of that is 1. Ibig sabihin lahat ng tao nag-respond sa solicitation mo. Okay? And yung minimum value niyan is 0. Ibig sabihin walang nag-respond dun sa solicitation mo. So therefore, your x may assume a number, okay, or may be assigned a number, okay, that is between 0 and 1. Okay? So, pwede ring proportion yung maging value ng ating random variable. So far, ito na yung mga na-encounter natin. We have mga na-encounter nating possible values that random variables may assume. Okay? Na-encounter na natin yung count. Okay? Na-encounter na natin yung count. So, pag sabi yung count, positive integer. Okay? Na-encounter na natin yung non-numerical or categorical. Okay? These are dummy variables. Ngayon, tatanda lang natin na na kapag ang ang ating random variable is categorical, there are certain operations that we can do, okay, on categorical variables that we cannot do on other types of variables. Okay? Or there are certain operations on, say for example, count variables that can be done, okay, that can be done on them, okay, but cannot be done on categorical variables. Okay? So, for example, hindi natin pwedeng i-average, or so, for example, hindi natin pwedeng i-add ang mga categorical values or yung mga value ng dummy variables natin. Kasi, pag in-add mo yan, ano namang sense? Okay? It doesn't make sense kung i-add natin sila. Dahil, for one thing, they don't really represent numerical quantities. They represent categories. Okay? So, we don't really add them, for example. Or we don't really average them. Okay? So, may mga bagay tayong, or may mga mathematical operations tayo that we cannot do on some types of your variables, okay, that we can do on others. So ayun, kaya careful tayo sa pagtingin kung anong types of variable that kung anong type of variable that we have. So we have count variable, count random variable, we have categorical, okay, na-encounter na natin tong proportion, okay. Okay, we have encountered proportion. Okay. Ang proportion is usually a number between 0 and 1. So we always remember that. Okay. We also have this sige, mamaya na yun, diba? Okay. Ito pala yung 3.7. So let x be a random variable, okay, defined by the waiting time in hours, okay, between successive speeders spotted by radar units. Okay, so ibig sabihin parang ganito. Merong MMDA. Meron siyang parang device. Parang, ano tawag nito doon? Speed gun ba yun? Okay, parang speed gun. Which measures the speed of a moving vehicle. So parang binabaril lang, hindi binabaril, parang tinututok nila sa isang moving vehicle. Tapos na-measure nun yung na-measure nun yung speed ng vehicle na yun. Okay. So, ayun. So that MMDA personnel, okay, of course waits, okay, waits for him to 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 measure or to measure the speed of a vehicle na over sa speed limit. Okay, yun yung speeders na tinatawag. So, ang sinasabi niya dito, yung X dito, is the waiting time in hours, okay, between successive violators, okay, of speed limit that is spotted by a radar unit. Okay? So, in this case, maaring yung waiting time na yan, okay, maaring it can be as short as as 0. Baka dalawang magkasunod na speeding kasi nagkakarera sila. So dalawa kagad nahuli nung MMDA natin. So it can be as short as 0, okay? Or it can be as long as, say for example, X hours. Okay, it can be as long as X hours. Okay? So now what we can say here is that your random variable here, okay, would take on values that are what we call what we consider a continuous variable. Okay, a continuous variable. Paano naging continuous variable? Kumbaga, yung X mo, pwede siyang mag-assume ng 0. Okay, pwede siya mag-assume ng say 1 hour. Okay, pwede siya mag-assume ng 0.5 hour. Okay, pwede siya mag-assume ng 2.25 hours. Okay, pwede siya mag-assume ng 1.75393 hours. Okay, and so on. So, meaning, for a certain interval, okay, there are infinitely many values that your X can assume. Okay? Sa pagitan, for example, sa pagitan lang ng 0 at saka ng 1 hour. Okay? Yung number of or yung possible values that your X can assume here is infinitely many na. Okay? Kasi pwede siyang 0, pwede siyang 0.01, 0.000001, okay? Pwede siyang 0.05, 0.0253, and so on. Okay? So, ito yung tinatawag nating continuous variable. Okay? So, ayun. Isa pa yan sa mga natin. Okay? So, you now have here a continuous value. Okay? So, it means that there are infinitely many values the variable can assume at a finite interval. So kahit na finite yung interval, ibig sabihin kahit may limit yung natin, waiting hours natin. Say for example, ang maximum waiting hours mo ay 2 hours. Okay. Even so, within 0 to 2 hours, yung i-assume na value ng X mo is infinitely many. we consider x now, or we consider now that your random variable is a continuous variable. Okay. Iba yan dito sa count. Okay, which is considered to be discrete. Okay. This is considered to be discrete. Okay. So, discrete value. So, paano naman siya naging discrete value? Dahil, ayun lang, yung meron lang certain allowable values like 0, 1, 2, 3, 4. Okay. So, dahil count siya. Okay. Although, meron ding mga random variables that can take on not necessarily positive integers. Okay. Pero discrete yung value na i-assume niya. Say, ang pwede niya lang i-assume na value ay 0, 1.5, 2.5, 3.5, 4.5, and so on. Yun lang. Okay. So, hindi siya count because 1.5 doesn't depict a count. Pero discrete value siya. Okay. So, let's place it as a different category. So, discrete value. Okay. Can take on only possible allowable values. So, there are certain values that are allowed. Okay. So, ayun. So, these are the possible values that your random variable might assume. Okay. So, na-explore natin siya from example 3.1 hanggang example 3.7. Okay. So, here, let's read on definition 3.2. If a sample space contains a finite number of possibilities, okay, or an unending sequence, okay, with as many elements as there are whole numbers, okay, it is called a discrete sample space. Yun. So, kapag yung sample space niyo, okay, has a finite number of possibilities. Ibig sabihin yung size ng sample space nyo is finite. Okay. O kaya, pwede rin naman siyang infinite. Okay. But, the number of elements, okay, can be as many as a whole number. So, which means na kung ang number of elements ng na sample space nyo is infinite, okay, but we can distinctly count each sample space. Okay? We call that as a discrete sample space. Okay? So, halimbawa in this case, we can say that this is a discrete sample space. Yeah, this is a discrete sample space. Because there are only 4. Okay, 4 elements of your sample space. So, finite. Okay. Also this is a discrete sample space. Because there are only 1, 2, 3, 4, 5, 6. 6 elements of your sample space. Okay. Ito is yung isang example niya, yung unending sequence of elements. Okay? But if we can determine na the number of elements here, okay, can be counted as 1, 2, okay, 3, 4, and so on. Okay? Still, this is considered to be a discrete sample space. Okay? So, since we are able to count the number of elements, okay, of the sample space as if we are counting them as whole numbers. Okay? So, that's what we consider as discrete sample space. Okay? So we remember that now. So the outcomes of some statistical experiments may be neither finite nor countable. So maaaring kapag nag-conduct tayo ng, ng statistical experiment, we may not be able to count the outcomes. Okay? The number of possible outcomes. Okay? Pwedeng infinite siya talaga, or pwede naman siyang finite, kaya lang hindi talaga siya mabilang kasi sobrang dami niya. Okay? So, such is the case, for example, when one conducts an investigation, okay, measuring the distances that a certain make of automobile will travel over a prescribed test course on 5 liters of gasoline. Okay? So, for example, yung experiment natin involves trying out a automobile model. Okay? So, meron tayong certain automobile model. And then, lalagyan natin siya ng 5 liters ng gasoline. Okay? And then, i-measure natin yung distance. Okay? I-measure natin yung distance na kayang i-travel nung automobile model na yun. Okay? So, in that case, ang outcome kasi natin doon is the distance. Okay? So, that might be also our random variable. Okay? So, assuming distance, okay, to be a variable, measured to any degree of accuracy. Say, for example, yung distance natin, i-measure natin until, or correct to, say, centimeter. Ay, hindi. Wag naman. Kilometer. Sige, correct to centimeter. Okay. So, which means, ano yan? Maaring, yung degree of accuracy na sabi dito is, say, we will measure that distance up to centimeter. Okay? So, say, for example, pwede siyang, pwede siyang mag-travel ng, say, 4,112 meters, 4,012.99 meters. So, yung 2 decimal places na to, okay, yan yung nagre-represent ng centimeter degree. Okay, yung centimeter na reading. Okay, ibig sabihin, it is possible na makabasa tayo ng distance, okay, na 0, 0, 0, 0, 0, 0, okay, up until, say, 10, 0, 0, 0, 0, 0, and so on. Okay? But even if, okay, makabasa ka between 0 from here to 001.00. Okay? Meron ng 100 na values. Okay? Meron ng 100 na values that your X or that your outcome can assume. Okay? Meron ng 100 values. Paano kung hanggang dito pa? Kung simula dito hanggang dito. So, hindi na siya, finite siya. Okay? The distance is finite kasi 10 kilometers lang naman to or 10,000 meters lang naman to. Okay? But the number of possible values that your outcome can assume, okay, or that your random variable can assume, is infinitely many. Ito yung sinasabi natin hindi countable. Okay? So, ayan. Finite siya pero hindi countable. Okay? So, clearly, we have an infinite number of possible distances. Okay? In the sample space that cannot be equated to the number of whole numbers. Okay? So, hindi natin siya hindi natin siya mabibilang na as a whole or in parallel to how we count whole numbers. Okay? So, that's one example. So another example is if one were to record the length of time, okay, for a chemical reaction to take place, okay. So depende sa sa accuracy nung pagbasa or pag-record ng time. Say for example, we can record the time correct to say tenths of a millisecond. Okay? So pwedeng magsimula tayo sa 0.0 millisecond. Okay? Hanggang say for example 1,000.0 millisecond. Ano yan 0 to 1 second pa lang yan. Okay? But take note na from 0 hanggang 1.0, from 0 millisecond hanggang 1 millisecond, meron ka ng 10 values. Okay? 10 values of time. Okay? That is 0.0 millisecond, 0.01 millisecond, 0.02 millisecond, hanggang 1.0 millisecond, 10 values na yun. Pero ito bilangin nyo, from 0 millisecond up to 1 second. Okay? So, yung 0 millisecond nyo hanggang 1,000 millisecond nyo, okay? That's a finite interval. Okay? But, yung number of values na pwede nyo makuha dyan, okay? Pwede nyo pwede nyo makuha dyan sa interval na yan. Okay? That is accurate to tenths of a millisecond is infinitely many. Okay? So kapag ganito yung case, okay, pagka ganito yung case nung numerical values ninyo, okay, again, this is infinite in number and uncountable. Okay? So these sample spaces are not discrete. Okay? Hindi na discrete yung sample space natin. But rather, okay, it's a continuous sample space now. Okay? So here, by definition, if a sample space contains an infinite number of possibilities equal to the number of points on a line segment. Okay? Remember that a line segment, okay, has two endpoints. Tapos pagdudugtungin natin ng line. Okay. Take note that that this line has a finite length. Okay. This line has a finite length. Okay. Yung length nung line segment nyo, finite yan. Okay. But if you actually count how many line segments are there? Okay. I mean, how many points? Okay. How many distinct points are there between, say, point A and point B? Okay. There are actually infinitely many points. Okay. There are infinitely many points between A and B. So, pansinin nyo na yung scenario na to, kung paano siya naging pareho nito at saka pareho nito. Okay? Again, yung endpoints ninyo maaaring countable. Okay? Maaaring countable sa atin yung endpoints ninyo. Okay? But the values in between, okay, the values in between these points has many values, okay, or can assume many values. Okay, so therefore, in this case, we will assume your sample space to be a continuous sample space now. Okay, so if we obtain our random variable from a random sample space, okay, we consider now your random variable to be a discrete random variable. Okay, and we will know that because the set of possible outcomes for your random variable is countable. Okay, kung mabibilang natin yung number of variables, or I mean the number of values that your variable can assume, okay, then we will consider that random variable to be a discrete random variable. So we say here that the random variables in examples 3.1 up to 3.5, okay, are discrete random variables. So ito yun. Ito, yung number of balls, red balls. Okay, yung number of correct arrangement. Okay. Ito, since your random variable takes on two values, 1 or 0. So, discrete yet. Okay. Here, since your random variable takes on values from 0 up to 10, so discrete din siya. Okay. And ito, so discrete din ito, no? Okay. Now, recall dito sa 3.5 that your x, okay, may take on 0, 1, 2, 3, 4 up to infinity actually. Okay, pwedeng yung pwedeng yung x niyo may assume a value of infinity. Okay? It may assume a value of infinity. Okay, but still we consider this random variable, okay, to be a discrete random variable because even though the number of possibilities or the number of values that it can assume is infinitely many, okay, it is infinitely many, that many is actually equivalent to the number of whole numbers. Okay? Again, kung ang ating sample space, okay? If our sample space or if the number of sample points in our sample space is infinitely many but equal to the number of whole numbers, we consider this sample space to be a discrete sample space. Okay? And therefore, the random variable that is associated with that sample space to be a discrete random variable. Okay? So, ayun. Remember this definition. Sample space contains finite number of possibilities or an unending sequence with as many elements as there are whole numbers. Ito yun. Unending sequence ito. Okay? Unending sequence ito. But the number is equal to. Okay? The number is equal to the number of whole numbers. Okay? So therefore, we consider the random variable here. Okay? The random variable associated with the sample space to be a discrete random variable. So, ayan. But a random variable whose set of possible values is an entire interval of numbers is not discrete. Okay? So, ito yung sinasabi naman natin tungkol dito. Okay? If the random variable, okay, can assume values that is or that includes an entire interval of numbers, okay, even if that interval is finite, okay, so we cannot consider those random variables to be discrete. Okay, so when a random variable can take on values on a continuous scale, okay, it is called a continuous random variable. Okay, so often the possible values of a continuous random variable are precisely the same values that are contained in the continuous sample space. Okay, so the possible values of a continuous random variable are precisely the same values that are contained in the continuous sample space. So kung ano yung outcomes nung kung ano yung kung ano yung sample points nyo sa sample space, okay, if it is continuous, then the variable or the random variable associated with that continuous sample space also takes those possible values. Okay, so obviously, the random variables described in examples 3.6 and 3.7 are continuous random variables. So ito, 3.6. Okay. So 3.6, even though proportion siya, no? Okay. Again, kahit na ang limit ng ano mo ay 0 to 1. Okay. Still, there are infinitely many numbers that are between 0 and 1. Okay. So that is why this proportion, okay, or this the random variable that denotes proportion is a continuous random variable. Okay. While ito obviously, naituro na yan natin to, nai-point out natin to, that the waiting time in hours, okay, maybe expressed in terms of or maybe expressed in terms of or as accurate, okay, as say for example up to minutes, okay, but still there are infinitely many values that can that your x or that your random variable can assume, okay, between time 0 and say for example time equals 1 hour. Okay, kahit na correct to minutes lang yung okay, so there. Okay, that random variable is considered to be this one, is considered to be a continuous random variable. Okay, so in most practical problems, ito yung tatandaan nyo ngayon. In most practical problems, okay, continuous random variables represent measured data. So if we are dealing with data or quantities that are measured, okay, then most probably this would fall under the category of continuous sample space, and therefore the variable associated with that is a continuous random variable. Okay. While discrete random variables would represent count data. Okay. So pagka nagbibilang lang tayo, okay. So for example, the number of defectives, they represent random, they represent discrete random variables. Okay. But also included in the discrete random variables are yung yung dummy variable ng categorical data. Okay. And included yung sa continuous random variable yung proportion. Okay. So we remember all those things. Okay. So that ends the discussion on the concept of random variable. Okay. We will discuss discrete probability distributions next.